Good afternoon, students. This is lesson 4.4, which is graphing a function rule. Let me go ahead and share my screen with you. I keep starting with the same words. I should probably come up with some different words. All right, lesson 4.4, graphing with a function rule. If you want to follow along in your book, it's on page 270. So the question of the day is, how do you go from an equation to a graph? So in other words, how do you go from this, some letters and numbers with an equal sign, to this, an actual graph where you graph a shape, usually a line, okay? Now I want to go into the different steps that are needed to do this. And I've written the steps out for you, and there's basically 7 steps, okay? Starting with your equation, you want to set up a table of values, okay? Now here on the side, I made a little equation, y is equal to 1/2 x minus 1. Now, you want to get a table of values, so go ahead and make a table with an x and y, and then you have to put in some convenient x values. So in this case, there's 0, 1, and 2. And we're going to actually do this in just a few minutes. I just want to go over the steps first. So you want to use your equation as the rule, okay? You know how when we were making some tables before, like we said, the rule is like 3 times x. So if x is 1, then y is 3. If x is 2, then y is 6, that type of thing, okay? So your equation is your actual rule. So in this case, I have y is equal to 1/2 x minus 1. So if x is 0, then it goes 0 times 1/2 is, well, 1/2. Oh, I'm sorry, 0 times 1/2 is 0, minus 1 would be -1. Okay, so then y would equal -1. So in this case, I have then 0, -1. So you solve to get your y values, okay? So put in your x values and then use x to get your y values. Use the x and y values as ordered pairs. So for example, my first value is 0, -1, then I turn that into the ordered pair 0, -1. And then I want to make a coordinate plane. The coordinate plane is pretty much just 2 lines on a graph paper, okay? It shouldn't be that hard to do. And then step 6 is you want to plot the points. So you go ahead and put the points down, and then you connect the points by making a line. Oops, sorry. The line's a little off here. So I know I went through that quickly. Let me just review the steps, and then we'll go ahead and actually do it. Number 1, set up a table of values. Number 2, use the equation as the rule. Number 3, solve to get the y values. Number 4, use the x and y values as ordered pairs. Number 5, make a coordinate plane. I put a little note here with proper intervals. We'll talk about what that means in just a minute. And step 6 is plot the points, and step 7 is to connect the points. Okay, so I have an equation here. Y is equal to -2x plus 1. Okay, so the first step is to set up a table of values. So to set up a table, now a table can be done from left to right, usually like this. Sometimes you can also do a table like this. And the book has these interesting tables in it where they sort of put like the equation in the middle of it. I don't particularly like that, but it is good for helping you to understand like the process. But either way, let's go ahead and put a table of values. Now, given that most graphs are usually fairly small numbers, then you want to start with numbers that are fairly close to 0. Now, the standard numbers to use for your x values are -2, -1, 0, +1, and +2. Why? Because those numbers are fairly easy to understand, even the negative ones, and they are fairly easy to graph because they're close to 0. So my recommendation is to use these numbers unless there isn't a good reason not to. But the rule is to use convenient x values. Convenient means x values that are going to make it easy for your graph to be made. Okay, so if like 78 is your favorite number, good, you can use 78 and it will graph correctly, but it's probably not going to be the easiest number to graph. Okay, so you need a very large graph or very large intervals. So now let's use the equation here, y is equal to -2x plus 1, to solve this. Now, if I do it this way, y is equal to -2 times the value of x plus 1. Now, what I'm going to do is I'm going to use a pencil so that I can actually change my value here. So my first x value is -2. I'm going to go ahead and write -2 in there. Okay, now let's solve the problem. -2 times -2 would be what? Nico, that's right, +4. Now I have +4 plus 1. 4 plus 1. Yep, that's right, Aaliyah. That is 5. So y would equal 5. Okay, so that would be my first ordered pair. Now I'm going to go ahead and erase. Now let's do -1. -2 times -1 would be +2. +2 plus 1 is 3. So if x is -1, then y is 3. And that kind of shows the cause and effect relationship. If the cause is -1, then the effect is 3. Okay? Because remember, I said that your x value is your independent variable, the one that's causing something to happen. Your y value is the dependent variable. Okay? So now I'm going to erase again, and let's put in 0 as my x value. So 0 times -2, Isai, that's correct, would be 0. So if that's all 0, then 0 plus 1 is 1. So then y would equal 1. Now, in the book, what they did is they actually wrote out the equation like 5 times or so that, and they stuck this equation in between x and y, so it kind of had this really big table. I'll show you what it looks like after we're finished doing this. Or you can look at it in the book. If you have the book, I believe it's on, this question's on page 270. But continuing on, so if x is 1, 1 times -2 is -2. -2 plus 1, no, it's an integer question. Yep, you're right, Evelyn, you got it. Then if y is equal to -2 plus 1, then y itself would be equal to -1. Because -2 plus +1 would be -1. Okay, I'm going to erase again. All right, so the last x value then is 2. So let's put in 2. So -2 times 2 would be -4, plus 1 would be -3. Now again, if you're a little rusty with your integers, meaning positive and negative numbers, you may want to use a calculator to do some of this. And some fancy graphing calculators you can just press a few buttons and it'll give you this whole table like really quick. But um, I'm not saying that that way it's better or worse. It's just, if you've got the equipment, you may want to use it. Okay, so let's take a look at the steps again. The first step was set up a table of values. We did that and we put in the convenient x values. Use the equation as your rule. So this was our rule here. And then solve to get the y values. So we actually had to solve 1, 2, 3, 4, 5 equations to get the 5 y values. Now, use these as ordered pairs. Now, it's not necessary that you write them as ordered pairs. This is an extra step that I'm just doing to ensure that we all understand the process here. Okay, so when we write ordered pairs, the standard way of doing it is to put them in parentheses. The x value always comes first and the y value always comes second. Now, in contrast with the equation, generally speaking, the y comes first and the x comes second. So please don't be confused by that. When the y is isolated, then it's much easier to get a y value because then you can solve for y by isolating it. You can also write your equation backwards, like negative 2x plus 1 is equal to y, if that helps. I know sometimes with math it gets a little bit confusing because you do certain things, like the tables are always from left to right, but the equations from right to left. So, please, if you're aware of those things, then they usually won't be confusing. All right, now, the next step is to make a coordinate plane with proper intervals. So, to make a coordinate plane is fairly simple. Now, I didn't go into a lot of detail on making a coordinate plane because you probably should have already known how to do that from pre-algebra or whatever class you took before you were taking this one. So I have my x-axis and my y-axis. Together they make a coordinate plane on graph paper. Now, in the step it said to make proper intervals. So what I mean by proper intervals is using numbers that are going to be able to graph your numbers here. Now, as I can see, the highest number that I have is positive 5. Okay, so what that means is that my intervals should probably go at least as high as my highest number. Oops, I wrote positive 2, negative 2, negative 3, negative 4, and negative 5. Okay. All right, so now what we want to do is we want to plot our points. So my first point is negative 2, 5. We always start at the origin, which is the center of the graph, and its number is 0, 0. So negative 2 is my x-coordinate. So on the x-axis, I go to negative 2. My y-coordinate is positive 5. So pertaining to the y-axis, I go positive 5. That would be my first point. Okay. I'm just drawing a really light arrow there just to show where I'm putting that. So my x value is negative 1. My y value is positive 3. Okay, my x value is 0, so I just stay there. I don't go down any, I don't go up any. I just stay on the origin for 0. But my y value is positive 3. Wait, is that right? Because that's not going to be linear. I think oh no, I just wrote the wrong number. That's what the problem was. See, it was 1 there, and I wrote it as 3 here. Must have been looking at something else. Okay, good thing I checked. So if it's 0 to the left, 0 to the right, then I go up 1. So there's my next point. Then I have 1, negative 1. So my x value is positive 1, and y value is negative 1. Now, as you can see here, I kind of wrote a dot over one of my numbers. Sometimes that's going to happen, okay? And then my x value is 2, so go over 2. My y value is negative 3. 1, 2, 3 down. Okay, so now I have plotted the graph or the dots. So then I want to connect the dots to make the shape. Okay. Now I'm just using these light colored lines just to show where the connection between the equation to the table to the ordered pairs to the graph. Okay, so that was the thing that I really wanted to establish. How do you get from this to this? Okay, now in the next question, and this is a question directly from the book, it's problem 2. I believe it's on page 271. It's talking about graphing a real world function. Okay, now in graphing a real world function, sometimes you're going to have intervals that are going to be much larger. Now, I'm not going to go through and graph this one. It's actually graphed in the book, and here I'll just show you the problem. See, it has one of those big tables where you have your x value and your y value, and then all of this work in the middle of it. Okay, simply put, well, I'll just kind of point out everything that's here in the middle of your table. Here's your x value. It actually calls it c, and here's your y value. Well, actually, that's CW, which is X and Y. I'll talk about that in just a second. What it did is it did all of the work here in the center, and essentially that's just the same thing as what we did right here, where we erased the X values and then added, and then did it again, okay? It just did it a bunch of different times. So what I'm getting at is when you have values that are considerably larger than like 1, 2, and 3 kind of numbers, then when you set up your intervals, you want to set them up in comparison to the numbers in your in your in your problem or in your equation. So this is 146, the value that we would associate with x. So on this side, you might want to go 100, 200, 300. Okay, so in a sense, your graph here is just showing information. The information should be written in such a way that it's going to match your problem. So if you're having numbers, you know, in like the 10,000 range, like 30,000 here, then obviously if you have a graph that starts with numbers like 1, 2, 3, that's not going to help you. Okay. Now, another thing I want to say about real world problems. In a lot of real world problems, the numbers are only going to be positive. Like, for example, if you have a problem that involves the weight of something. So in a real world problem, you may not necessarily need to have negative numbers. Now, like in our graph that we did here earlier, um, as you can see, we did have quite a few negative numbers in the graph, okay? And things were actually graphed, oops, sorry, I went too far. Things were actually graphed on the negative sides of the coordinate plane. But in the next graph, if we were to graph the information, everything is going to be written as positive, okay? So your graph Now again, I'm somewhat copying from the book here because I didn't want to take the time to multiply and then add all of these numbers. Um, because this particular graph is dealing with, I think, the amount of weight that goes into a truck, then you can't have negative weight, so it wouldn't make any sense to go past here or to take the graph further down into here, okay? I want to remind you, in a coordinate plane, all of the values that are in the top right corner are going to be positive, okay? And the other three quadrants in the coordinate plane are all going to have some negative numbers in them, okay? So if your values are only positive, then it would make sense to um, just use the values that are in um, quadrant one. Okay, I hope that helps you to understand. Thank you very much.